Galaxy cluster collapse, the largest scale destruction in the universe? In the vast cosmos, the formation and evolution of galaxies are deeply intertwined with movements, interactions, and sometimes violent destruction. One of the most awe-inspiring and large-scale phenomena is the collapse of galaxy clusters. This process not only represents a natural part of the universe's life cycle, but also serves as a reminder of the power of gravity and how it has shaped cosmic structures over billions of years. Galaxy cluster collapse not only presents a scene of destruction, but also helps scientists better understand dark matter, dark energy, and the fundamental forces shaping our universe. Galaxy clusters, cosmic giants. Galaxy clusters are colossal systems comprising hundreds or even thousands of galaxies bound together by gravity. These are the largest known structures in the universe, with masses millions of times greater than that of the Sun. However, these clusters don't remain in a state of balance forever. The complex interplay of gravitational forces, galactic dynamics, and the influence of dark matter leads to phases of conflict, merging, and eventual collapse. The process of galaxy cluster collapse. The collapse of a galaxy cluster often begins when two or more massive clusters move closer under the influence of gravity. Initially, the interaction is mild, with peripheral galaxies being pulled out of position and drawn into the overlapping region. Over time, the clusters converge, creating violent collisions between hot gas, dark matter, and the galaxies themselves. A prime example of this is the Bullet Cluster, where two massive galaxy clusters collided at speeds of thousands of kilometers per second. Observations of the Bullet Cluster have provided critical evidence for the existence of dark matter, as most of the cluster's mass does not reside in the visible galaxies, but in a mysterious form of matter that does not interact with light. The role of hot gas. Hot gas within clusters plays a crucial role in their collapse. During collisions, this gas is compressed, creating shock waves with temperatures reaching millions of Kelvin. Observations using X-ray telescopes, such as the Chandra X-ray Observatory, have detected these shocks in many collapsing clusters. The hot gas not only forms striking structures, but also emits intense radiation, offering valuable insights into dark matter and other cosmic phenomena. Dark matter, the invisible force. While galaxies account for a small fraction of a cluster's total mass, the majority lies in dark matter. Modern cosmological models, such as the Lambda CDM model, cold dark matter with a cosmological constant, suggest that dark matter not only provides the gravitational glue holding clusters together, but also dictates how they interact and collapse. Observations of cluster collisions, like those in the Bullet Cluster, have helped validate these models while raising new questions about the nature of dark matter. Impact on individual galaxies. The collapse of galaxy clusters also affects their constituent galaxies. Many smaller galaxies are torn apart by tidal forces, while larger ones may merge to form massive, luminous galaxies. For example, in the Abell 1689 cluster, merging galaxies have created brighter, more massive structures. A cycle of destruction and rebirth. Galaxy cluster collapse is not merely about destruction. It also represents restructuring and renewal. As clusters merge, they form new structures with greater mass and energy, shaping the large-scale architecture of the universe. Studies of collapsing clusters provide crucial insights into the evolution of the universe, from its early days after the Big Bang to the present. Stability and diversity in galaxy clusters. Not all galaxy clusters undergo dramatic collapses. Some, like the Virgo cluster, appear relatively stable, showing little evidence of major collisions or collapses. This variation raises intriguing questions about how gravity and dark matter influence the development of cosmic structures. The role of dark energy. Another critical factor in galaxy cluster evolution is dark energy, which accounts for about 68% of the universe's total energy. Dark energy not only accelerates the expansion of the universe, but also affects how clusters interact and merge. Recent observations suggest that dark energy may limit the formation of massive galaxy clusters in the future, as the accelerated expansion of space prevents them from coming closer under gravitational pull. A lesson in cosmic evolution. The collapse of galaxy clusters is more than a physical phenomenon. It offers profound insights into the interconnected and ever-changing nature of the universe. Despite its apparent chaos and destruction, this process is essential to the formation of larger and more complex cosmic structures. Advances in observational technology, such as the James Webb Space Telescope and next-generation X-ray telescopes, promise to uncover new details about collapsing clusters. With better data on dark matter, hot gas, and galactic interactions, scientists can answer fundamental questions about how the universe works and evolves. The phenomenon of galaxy cluster collapse is not just a story of destruction. It is also a tale of connection and evolution in the universe. From violent collisions to the formation of new structures, it highlights the power of gravity, the role of dark matter, and the infinite complexity of the cosmos. By continuing to study this phenomenon, we gain not only a deeper understanding of the universe, but also of our own place within this vast and dynamic cosmic landscape.